These are my predictions for paper 2 Edexcel IGCSE Chemistry Exam 2025, and this is for paper 2C, not for the 2CR. The first topic is the solubility and solubility curve. This topic hasn't been in the exam lately, and it used to be one of the hot topics in paper 2. So my prediction that it might be, or please consider that it might be in the exam this year. So in solubility, the question when it comes, usually they provide you with data for solubility of a certain compound in water, and they ask you to plot this data in a graph. And then the most common question is to ask you to calculate the mass that will crystallize when you cool the saturated solution. The solubility curve is a curve of the temperature versus the amount that dissolve at a certain temperature. So the solubility, how much dissolved in 100 gram of the solvent, because solubility is the amount of substance in gram that completely dissolves in 100 gram of the solvent. Solubility changes with increased temperature. Most of the time, especially with solids, it tends to increase. So when you do the crystallization, recrystallization process, you tend to cool your solution. And when you cool your solution, some of the solids will crystallize out of the solution. So they ask you to calculate how much crystallized. Remember, to do this, you need to calculate the difference between the solubility of that substance at these two temperature, and that difference will be how much will crystallize. And then the second topic is ionic bonding. So ionic bonding is usually one of the topics that come in paper 1. However, if it wasn't in paper 1, it might be in paper 2 because it's common to come, especially in comparison with metallic bonding. The most common types of questions that come with ionic bonding in paper 2, if it wasn't in paper 1, are related to the high melting points of ionic compounds, which comes from the strong electrostatic process of attraction between the oppositely charged ions in the giant ionic lattice, and a lot of heat will be needed to break these bonds. Also, the electrical conductivity of the ionic compounds. Remember, they do not conduct electricity as solids, as there are no free ions to move because the ions are held in the giant ionic lattice. They can conduct electricity in two other cases. The first one when molten, the second one when dissolved. This is because the ions are now free and they can move and carry charges. As I said, this usually comes in comparison with metallic bonding because metallic bonding is very common in paper 2. And in metallic bonding, they usually ask about the melting point and the type of the bond. So there are these are strong bonds. They come from the electrostatic forces of attraction between the positively charged ions and the delocalized electrons. So these are the positively charged ions, and these are the delocalized electrons that can move around. And they tend to ask about the properties and to explain these properties. The first one is the high melting points, and we talked about the high melting points due to the electrostatic force of attraction. And then they ask about electrical conductivity and malleability. So electrical conductivity, they can conduct electricity because they are the free delocalized electrons that move through the structure and carry the charge. And then malleability is due to the regular arrangement of the layers that can slide over each other when hammered. And then they ask about alloys. So very common to ask you about alloys and why alloys are harder. So alloys are made up of the metal atoms and in addition to some another metal or non-metal that is added. So another element that is added to that metal, and they become harder. That makes them harder than the pure metal because the different size of the atom will distort the regular arrangement of the atoms, making it more difficult for the layers to slide past each other or over each other. So they become harder, not as malleable as the pure metal or ductile. And then they can sometimes ask about uses of metals when they ask about metals. The most common one probably is aluminium. Remember that aluminium doesn't corrode like iron, and this is because the formation of a layer of aluminium oxide on top of the aluminium that protects aluminium from corrosion. Reactivity trends in the periodic table, it's also common, and they tend to ask about group 1 or group 7. So remember that for group 1, as you go down the group, the reactivity will increase. And the increase of the reactivity is because the outer shell electrons becomes further away from the positively charged nucleus. So the electrons have less attraction with the nucleus and it becomes easier to remove. So it's easier to form the positively charged ions, so they become more reactive. And then the explanation for the group 7, as you go down the group for group 7, the reactivity will decrease. The decrease of the activity is due to the outer shell electrons are further away from the positively charged nucleus. So the electrons will become easier to gain in this case as you move down. Remember that group 1, the reactivity comes from loss of electrons. Group 7, the reactivity comes from gaining the electrons. The type of reactions for group 1 and group 7 are also very common. So for group 1 metals, alkali metals, remember the reaction with water will give you the hydroxide and the hydrogen, and you can judge the reactivity based on how much bubbling you can see when you add the metal to the water. As you go down, the reaction becomes more vigorous, and they tend to ask you about the observations for this type of reaction. The second reaction with oxygen, they react with oxygen to give metal oxides, and then reaction with chlorine, they react with chlorine to give metal chloride salts, which are white salts. Again, reactivity for all of these will increase down the group. Sometimes they ask you to write the equation as well for a reaction between one of the metals and with chlorine. And for example, here, sodium and chlorine will give you sodium chloride as a solid. For the halogens, because we are talking about the reactivity trend, so they tend to ask about the displacement reactions for the halogens. So the more reactive halogen can displace the less reactive one. A displacement reaction will occur between a more reactive halogen and a salt of the less reactive one. So as we said, as we go down the group, the reactivity will decrease. So chlorine will be more reactive than bromine and iodine. So chlorine can displace the bromine from its salt. So you can react chlorine with potassium bromide to give you potassium chloride and bromine. So now the chlorine displaced the bromide. And also it can do the same with the iodide. So chlorine more reactive than iodine. So when you react chlorine with potassium iodide, that will give you potassium chloride and iodine. And remember the change in the color of the solution. So if you start with potassium bromide, which is colorless, that will give you bromine, which is orange on color. And if you start with potassium iodide, which is colorless, that you're going to end up with iodine. The solution will be brown because of the iodine that is formed. And also remember that the iodine itself cannot displace the bromine or the chlorine. So if you have iodine reacting with potassium bromide or potassium chloride, there will be no reaction. Reactivity series and extraction of metals, very, very common in paper 2, and I would expect that to be in the exam. So here in the reactivity series, what's important is the extraction of metals. So they tend to ask you why this particular element cannot be extracted from its ore using carbon. Remember that the metals which are below the carbon in the reactivity series can be extracted using carbon, but the ones which are above the carbon in the reactivity series cannot be extracted because they are more reactive than carbon. So something like aluminium, so they tend to ask you why aluminium cannot be extracted from aluminium oxide using carbon. This is because aluminium is above carbon in the reactivity series and the carbon cannot displace the aluminium. However, what type of extraction can we use? We can use the electrolysis. So in electrolysis, electrolysis, we should know about electrolysis. And the electrolysis here is very common in paper one. So electrolysis is the split by electricity. You have two electrode, a cathode and anode, or you have a positive electrode and a negative electrode. And then you have an electrolyte. So they tend to ask you about the electrolysis of either molten ionic compound or the aqueous solution of an ionic compound. What are the product? They tend to ask you what happens at the negative electrode, or how this is formed at the negative electrode or at the positive electrode. Remember, this is a redox reaction, and they will ask you normally to write the half equation that happens at either of these electrodes. For the molten ionic compound, the cation or the positive ions will move towards the cathode, which is the negative electrode. They will gain electrons or get reduced, and they will form the metal. And then for the positive electrode, toward the positive electrode, the negative ions, like here, if we are talking about sodium chloride, the chloride will move towards the positive electrode. They will lose electron, get oxidized, and they will give the chlorine. Remember how to write the ionic equation or the half ionic equation for the reaction that takes place at both the positive and negative electrodes. And then electrolysis of aqueous solution. Electrolysis of aqueous solution, we have now a different thing that happens because we have the ionic compound, which has a cation and an ion, and we also have the water molecule. So water tends to ionize to give you hydrogen ions and hydroxide ions. Now there will be competition at both the positive electrode and negative electrode. So at the negative electrode, there will be competition between the metal and the hydrogen from water, hydrogen plus from water, and the metal itself. So which one is going to be reduced at the negative electrode? If the metal is below hydrogen in their activity series, like copper, then the copper is the one that is going to be reduced to change from copper plus ions into the copper metal. If the metal is above the hydrogen in their activity series, then the hydrogen ions is the one that's going to be reduced, and the hydrogen ion will give you the hydrogen gas. What about the positive electrode? At the positive electrode, there will be competition as well. The competition this time will be between the anion from the ionic compound and the hydroxide from water. So if the anion is a halide, then the halide tends to be oxidized at the positive electrode and will give you the halogen. So if you have chloride, you will get chlorine, bromide, bromine, and iodide, you will get iodine. But if you have any other anion like sulfate, nitrate, anything else other than one of the halides, then the hydroxide is the one that is going to be oxidized and will give oxygen at the negative electrode. Remember that they will usually ask you to write the half equation at either the positive or the negative electrode, and they will ask you why this is oxidation and why this is a reduction. Remember the oil rig, where oxidation is the loss of electron and reduction is the gain of electrons. Acid-base titration, this is very common, not just very common, definitely you're going to have a question about acid-base titration in your question. So what type of question they tend to ask about acid-base titration? They tend to ask you about the method, how to carry out the titration. Sometimes they ask you how to do this titration with the 6-mark questions. Sometimes they get you photos or pictures of the apparatus used, the burette and pipette used in the process, and they ask you to name them. So make sure that you know all of that. Make sure that you know your indicators that you use for the acid-base titration, litmus, phenolphthalein, and methyl orange, and the change in the color between the acidic solution and the basic solution. Remember that we don't use universal indicators for the acid-base titration. However, sometimes they ask you about universal indicators. What would be the color of the universal indicator if added to a different solution? So make sure that you know your universal indicators colors as well. You should be able to improve a titration method provided to you in the exam as well. So sometimes they provide you with the steps and ask you how to improve the method. Finally, you need to know how to calculate the concentration from titration, because definitely with the titration, they're going to ask you to do this calculation. Topic 8 is the energy level diagrams and calculation of the enthalpy using bond energies. So calculation of the enthalpy using bond energy is a guaranteed, almost a guaranteed question in your exam. I haven't seen paper 2 without this question. So remember that the delta H, when you calculate the enthalpy change using bond energy, it will be equal the energy gained to break the bonds in reactants minus the energy lost to make the bonds in the products. So calculate all the bond energies for all of the reactant first, and then take away from that the bond energies of all of the products. If the type of bonds and number of bonds for both reactants and products are exactly the same, even though we have different compounds, then the enthalpy change will be zero, because this is a very common question in your exam. Remember that delta H will be negative value if the reaction is exothermic, and it will be positive if it is an endothermic reaction. So what's an endothermic and exothermic? Because drawing the energy diagram is very common. So exothermic reaction, it is reaction when the reactants have energy more than the product. So when you draw the energy profile for an exothermic reaction, you put the energy of the reactants higher than the products. Don't forget to label the activation energy, which is the difference between the energy of the reactants and the highest point. And the overall energy change will be the difference between the energy of the reactants and product. As you can see, for this reaction, there will be an increase in the temperature because the reaction will release energy or release heat. The overall energy change here will be negative value. Endothermic reaction is the opposite. Well, the energy of the products will be lower than the energy of reactant, sorry, will be less than the energy of the products. Again, there will be heat will be taken in, the temperature will decrease, and the overall energy change will be a positive value. Don't forget, activation energy will always be the difference between the energy of the reactants and the highest point. Overall energy changed will be the difference between reactants and products. Sometimes they also ask you to calculate the enthalpy change from calorimetry. So if energy change from calorimetry was not in paper 1, expect it might be in paper 2. But if it was in paper 1, definitely not going to be in paper 2. What you're going to expect is the calculation of the enthalpy change using bond energies. Reversible reactions and position of equilibrium. It's not in every single exam, but it's very common, mostly embedded within other questions, especially in organic chemistry. So a reversible reaction is when you have a reactants that can give you products, and then the products react back to give you the reactant. So you have a forward and reverse reaction. The most common question here is to ask you what is meant by the dynamic equilibrium. Remember that dynamic equilibrium for the closed system tend to happen when the rate of the forward reaction is the same as the rate of the reverse reaction, and the concentration of the reactants and products are constant at equilibrium. They are not the same, they are just constant. And then sometimes they ask about the factors that affect the position of equilibrium, because the position of equilibrium could be either towards the reactants or the products. So these are the temperature. So the temperature will depend on which side is exothermic, which one is endothermic. So if the forward reaction is exothermic, meaning heat is released, and we increase the temperature, the system will tend to oppose this effect by pushing the reaction towards the reverse or forming more of the reactant. So they might ask you, how would that affect the yield of your reaction? And then the concentrations in case of solutions. So normally, because what happens, this is Le Chatelier principle. So what happens for equilibrium? If you increase the concentration of the reactants here, then the system will act to oppose that effect by pushing the reaction forward. So more of the product will be produced. And then pressure in case of gases. So for gases, it depends on the number of moles of both reactants and products. So if you increase the pressure, the reaction will move to the side which has the lower number of moles and vice versa. And finally, the use of the catalyst. The catalyst will not affect the position of equilibrium. It's very common, by the way, to ask you about the use of the catalyst here and what does it do. So the catalyst will lower the activation energy. It was common in paper one as well. So if it wasn't in paper one, they may ask you in paper two. And to draw the difference in on energy profile, show the difference with the use of the catalyst. So the catalyst will increase the rate of both forward and reverse reaction at the same rate. So it doesn't affect the position of equilibrium, but it helps to reach the equilibrium faster. Organic chemistry. So organic chemistry in paper two is about alcohols, carboxylic acids, esters, and condensation polymers. So first of all, the alcohols, when it comes to alcohol, they will tend to ask you about the manufacture of ethanol. So remember the two different methods for manufacturing of ethanol. The first one, fermentation of glucose to give the ethanol. They may ask you about the products and the optimum conditions. So the optimum conditions here is the temperature between 25-35 and the use it under anaerobic conditions. So in the absence of oxygen, they tend to ask why in the absence of oxygen. Remember that the oxygen can oxidize the alcohol further to carboxylic acid. And then the heat of ethene with phosphoric acid, catalyst with a temperature above 300 degrees and pressure between 60 and 70 atmosphere. For this question, so if this question comes, they usually ask you to compare between these two methods, and they will ask you as well about the conditions for the conditions for the synthesis of the or formation of ethanol from ethene. So remember the use of the acid catalyst, the temperature, and the pressure. Oxidation of ethanol, it's not very common in the exam, has been in the exam for so many years. So it might worth that you look at it because it might be this year. So ethanol can be oxidized by burning in air or oxygen through complete combustion to give carbon dioxide and water, reaction with oxygen in air to give ethanoic acid. This is the microbial oxidation, and this is why we do the fermentation in the absence of the air. And finally, heating with potassium dichromate and dilute sulfuric acid, and that will give you ethanoic acid. The acids and the esters are more common in paper two, even than alcohols. So, and with the esters, especially the esters, so the esters will definitely be in your exam. So make sure that you know your esters. So when it comes to the carboxylic acid, they tend to ask about the reaction of carboxylic acid with metals and carbonate. So with metals, that will give you the salt and hydrogen. With carbonate, they will give the salt of the carboxylic acid, and they will also give the carbon dioxide and water. So they tend to ask you about these questions. The reactions between acids and alcohols to give the esters, these are almost in every single exam. So acids can react with alcohols to give the esters, and the condition here, or what you need to add, is a catalyst, and the catalyst here is an acid catalyst. So you need to add an acid as a catalyst for this reaction because they tend to ask you about the naming the catalyst. So for the esters, they ask you usually to name the ester. So remember that the ester come from an alcohol and a carboxylic acid. And to name the ester, you need to name the part that come from the alcohol first and the part that come from the carboxylic acid. For example, if we react propanoic acid with methanol, the ester will be called methyl propanoate. So remember that we start with methyl from methane or from methanol, and then propanoate that comes from propanoic acid. They also tend to ask you to draw the displayed formula for the ester form. Please make sure that you know how to do that. Remember that esters are volatile and they have distinct smells. Polymers, the type of polymers which is in every single exam is the condensation polymers. So make sure that you know your condensation for, polymers. Make sure that you know how to write the structure and displayed formula for the polyester. So polyesters are the condensation polymers that come from the condensation of a dicarboxylic acid and a diol. So the reaction between ethane diodic acid and ethane diol here. So you have the OH group from the carboxylic acid and the hydrogen from the alcohol. So they tend to lose the OH from the carboxylic acid and hydrogen from the alcohol to give the ester, and that happens on both sides. Make sure that you know how to draw the repeat unit for the condensation polymer. Remember the small molecules that is produced in the condensation, which is the water molecules, because sometimes they tend to ask you what is the small molecule. Also for the esters. So for the esters, when you make the ester, the products will be ester and water when you react an acid with an alcohol. You should be able to identify the repeating unit for the polymer. And remember that some biopolyesters are biodegradable. This is why we call them biopolyesters. And then fractional distillation of crude oils and cracking. These are very common in paper one, but if not in paper one, if you didn't see any question related to this in paper one, then expect that they might be in paper two. Just make sure that you go over this topic only if it wasn't in paper one. If there was a question related to this in paper one, they will not be in paper two. Then making salts. So making salts comes in both paper one and paper two, and it depends on whether it came actually in paper one or not. But remember for making salts that you can make salt starting from an acid and insoluble base to make a soluble salt. And you can also start from two soluble reactants through the precipitation to make an insoluble salt. Remember the trend of solubility. So all the salts of sodium, potassium, and ammonium are soluble. The nitrate are all soluble. Chloride are soluble except for the silver chloride and lead chloride. Sulfate soluble except lead sulfate, barium sulfate, and calcium sulfate. Carbonate, they are insoluble except for the sodium, potassium, and ammonium. And finally, hydroxide insoluble except for sodium, potassium, and calcium. Gases in the atmosphere, this is one of the topics that comes usually in paper one, but it's very common in paper two if it wasn't in paper one. So if there was nothing related to gases in the atmosphere in paper one, please revise this topic because it most probably going to be in paper two. The type of question that usually come at the composition of the different gases in the atmosphere, their percentages, the environmental problem of carbon dioxide. Remember that carbon dioxide is one of the greenhouse gases, and it causes the global warming. So that is a very common question in paper two when this question comes. Also calculation of the oxygen in air from experiment, the percentage oxygen in using a certain experiment. If this wasn't in paper one, this might actually be in paper two because it's quite common in paper two. Most common calculations in paper two. So first one, as we said, is the enthalpy change using bond energies. The second one is the volume of a gas produced from a reaction. This is a definite question in your exam. And of course, concentration from titration. So, and then we have the chemical tests. So chemical tests in paper two are not very common, but make sure that you just go over them because sometimes they can ask you about one or two of the chemical tests, especially for the metals, like how to differentiate between iron 2 plus and iron 3 plus and so on. If there were a lot of chemical tests in paper one, maybe you wouldn't see any of these in paper two, but they are not, as I said, very common, but make sure that you revise them anyway. These equations are very important for the paper two. So remember these two triangles. The first one is the calculation of moles. So the number of moles equals the mass over the MR. And the second one is the the calculation of concentration, which equals the number of moles over the volume. And the volume here has to be in decimeter cubed. So if they give you the volume, and usually they do give you the volume in centimeter cubed, you have to change it into decimeter cubed by dividing by 1,000. Remember, the volume of a gas in decimeter cube will equal the mass of the gas in gram over the mR of the gas, which is basically the number of moles of the gas multiplied by 24. This is the volume of the gas in decimeter cubed. And then finally, the concentration could be gram per decimeter cube or mole per decimeter cube.